How you doing?
Good. How are you today?
Just fine.
Coming down the final stretch, huh?
Yep.
When is your final?
Next Wednesday.
Oh, not till next week. Okay.
Yeah.
All right. So what are we going to do today?
Let's see if it'll come up here. Yeah. Alright, so I just put that in the box there.
Okay.
Alright, if you go to there, right above Chapter 7 says Spring Final.
Okay.
Packet.
Mm-hmm.
We're going to do that.
Okay. Can you read that? Here, let me expand it a little bit. Maybe that. Does that look okay?
Nah, it's too small.
Okay, let me expand it a little bit more. Okay. What's the missing side here?
10. It's a...
Okay, because that's a 3, 4, 5. Right triangle, only it's a 6, 8, 10. Okay, if a triangle has side lengths of 12, 14, and 19, is it a right triangle?
Yes.
Yes, because...
Are you looking at number 2? Because isn't this...
Oh, excuse me. I forgot number 2. I skipped straight to number 3 accidentally. Here, hold on. Let me do this.
Yeah, I was going to say, that looks like distance formula to me.
Yeah, really. Okay, so what's the distance formula?
X2 minus, or the square root of parentheses x2 minus x1 close parentheses squared plus y2 y1 that comes to
What's the first one?
the first x value -9.
Okay, what's the delta x value? In other words, what's the difference between the two values?
4.
Okay, and you don't care if it's plus 4 or minus 4, because we're going to square it.
Right.
Okay, so that's 16. What's the difference between the y's?
Looks like 7.
Okay, so that's 49. So we're talking the square root of 65. Can you simplify that?
You have to round up.
Well, no, I'm not talking about rounding. I'm talking about leaving it in square root form, but can we simplify it? In other words, 65 is what? Doesn't factor at all, does it? Factors into 5 and 13, and the key to knowing that we can't simplify that is knowing that both of those numbers are prime. Since 5 and 13 are both prime, then 65 can't be simplified. So the answer is radical 65.
All right.
Okay, here let me move this down a little bit. Oh, I see. Excuse me. It's multiple choice. So the square root of 65 is which of those numbers?
It round to 8.
Right, because 8 squared is 64. So,
Right.
okay. So let's look at number 3. You have a calculator handy?
I do, yeah.
Okay. How are we going to tell whether that's a right triangle?
You just do 12 squared plus 14 squared, and then do the square root of that and see if it comes to 19 squared.
Well,
It does
not quite. What you said was not quite accurate. What you want to know is 12 squared plus 14 squared equal to 19 squared? If it is, you have a right triangle. If it is not, you do not have a right triangle. So, is it or not?
No, it is not.
Okay, that's all the further we need to go. If it's not, then it's C. The answer is no, because 12 squared plus 14 squared is not equal to 19 squared.
Right.
Okay. Okay.
I don't remember how to do these.
Okay. There's 2 ways to do this problem. They're telling us that that's a right angle, and they're telling us that this is 45 degrees.
All right.
Do we know anything else based on that information?
The triangle can be a 45, 45, 90.
Okay. So if we know one side of a 45, 45, 90, we know all 3 sides. Because here's a 45, 45, 90 basic triangle. 1, 1, square root of 2. So they're telling us one of the sides of this triangle is 6. What's the hypotenuse?
The hypotenuse?
Mm-hmm. This is your basic triangle. This is the one you always want to think of when you're thinking 45, 45.
Right.
So what's the scale factor between this triangle we're looking at and our basic one?
6 to 1.
Okay, so what's the hypotenuse?
3 to 1.
No. In other words, if your scale factor is 6 to 1, every side of this triangle has to be 6 times every side of this triangle. So if the hypotenuse of this triangle is square root of 2, what is the hypotenuse of this triangle?
Square root of 6.
What's 6 times square root of 2? 6 square root of 2. That's the answer. She doesn't want it in decimal. She said leave it in simplest radical form.
All right.
Well, let's go over this because I sense that you're not fully understanding it.
I see it. It's just a little lost on why you're doing 6 times the square root of 2.
Because the most important thing to determine between these 2 triangles is what is the similarity ratio is. The similarity ratio being the ratio of 2 equivalent sides. Well, this is one of the sides, this is one of the sides. So by dividing these, we get a similarity ratio of 6 to 1.
Right.
Which means every side of this triangle has to be 6 times greater than its equivalent side of the unit triangle. So if the unit triangle's hypotenuse is square root of 2, this one has to be 6 times that. 6 square root of 2.
Okay.
Okay? Now, there's another way to do this. You don't have to use similar triangles. If we recognize that this is 45 and this is 90, then this has to be 45.
Right.
And that makes this an isosceles triangle with this side being equal to that side. So what is AB?
6.
Now figure out BC based on the Pythagorean theorem. So BC is equal to what?
6 squared plus 6 squared.
Remember, when you're solving a right triangle, the first words out of your mouth always are square root of.
Okay.
Okay? So BC is going to be the square root of this side squared plus this side squared.
All right.
That's equal to the square root of 72, which simplifies into the square root of 36 times the square root of 2, which simplifies into 6 root 2. So even if you don't do it using the similar triangle ratio, you can still do this problem. You just have to recognize.
Putting it in radical form, I'm a little confused on what you're doing there.
Okay. So what is BC here?
BC? Bro.
It's the hypotenuse. So what's the hypotenuse equal to?
The square root of 6 squared plus 6 squared.
That's the square root of 36 plus 36, or the square root of 72. So now let's look at reducing the square root of 72. We have to find factors of 72, hopefully one of them being a perfect square. Well, 36 is a factor of 72, and it's also a perfect square. So that's one of our factors. The other factor is 2. You with me?
Yeah.
Square root of 36 is 6. So there's our answer.
So how come there's no square root sign around 6 after?
Well, I said the first words out of your mouth have to be square root of, not the last simplification of it. In other words, the answer to the question is the square root of 72. But that's not to say it can't be reduced. It can be, as we just did. The reason I tell everybody to make the first words out of your mouth square root is because most people forget that. If you ask people to solve for this hypotenuse, half of them would say 6 squared plus 6 squared. And they forget that it's the square root of that.
Well, my question was not, I understand that part.
Okay.
It's when you're finding it in radical form, you said that the square root of 72 is equal to root 36 and root 2.
Okay.
Now, then you
that's based on the principle that the square root of AB is the square root of A times the square root of B. In other words, whenever I'm taking the square root of the product of two things, I can always separate it. So I can always split up 72 into whatever two factors I want. I could have said...
I understand that. It's
okay.
Why isn't there, when you can't reduce 2 anymore, but you can reduce 36?
Because 36 is
to fix 2, how come there's no radical around it?
Well, because the square root of 36 is 6. It's a perfect number.
So then you don't need the radical around it?
Right. In other words, all I'm doing is replacing the square root of 36 with the number 6. I still have the square root of 2 left over.
Okay.
Okay, let's just go through some others of that to make sure you're down with this principle, because this is pretty key. Simplify that for me.
So that can be down to radical 10, radical 2.
No. Radical 100,
Right, sorry.
radical 2.
And then I can
It's not radical 10. In other words, radical 100 is equal to the number 10.
right,
So that's the answer.
right, that's what I meant.
Okay. Okay. How about 80? Simplify that.
Alright, it could be, couldn't it come to 10 and 8?
Well, it can. The problem with that is that neither one of those is a perfect square.
Right, and then you can go down to 5 and 4.
What do you mean?
Oh, never mind. Can't do that.
So, in other words, when we're finding factors for 80, we want one of those factors to be a perfect square because we want to get rid of the radical sign on it if we can.
Okay, so 2
Whereas
and 4.
8 and 10 doesn't work. But how about
2 and 4.
16 and 5? That works much better, notice, because 16 is a perfect square. So that simplifies to 4 root 5. So there's your answer. Okay?
Okay.
All right, let's go to the next one here. A piece of art is in the shape of an equilateral triangle with sides of 7. Find the area of this.
Area for a triangle is base times height divided by 2. How do you get the height, though?
Well, drop a perpendicular like that. We know this is a right triangle. What's this angle here? What's angle A? Because it's an equilateral triangle, all three angles are equal.
Oh, so then 45?
No. A is equal to C is equal to B. What do they all three have to total?
90?
What are the angles in a triangle total?
180?
Okay. So if A is equal to C is equal to B, what is A?
And I'm not sure.
They all are equal and they total 180. Have to each be 60, don't they?
Wouldn't one have to be 30 then?
Well, the big angle is 60. Let's start with that. Once we've dropped the altitude, this is 30 because it's bisected.
Right, I see where I got myself mixed up
Okay,
there.
so we don't care about this half here for the moment. What we're trying to do is solve for this height because the area is equal to 1/2 base times height. Well, we know the base, but we don't know the height. So now we have enough information to solve for this height.
Okay.
So how do we do it? We can do it once again a couple of different ways. What is the distance from A to this altitude?
Half of 7, so 3.5.
Okay. Now, how would you like to solve for H? You can either use the Pythagorean theorem or you can use similar triangles.
Wouldn't that make H 3.5 as well?
No,
Or
this
no,
is 36.
never mind.
This is not a 45-45.
Right, so the hypotenuse would stay 7. So then you just do the square root of 7 squared minus 3.5 squared.
Good.
And then the height is 6.6.
Okay. 6.6?
06, sorry, 6.06.
6.06. Okay. So you've got the height, you've got a base. So what's the area? What's the formula for the area if I plug in here?
Base, which is 7.
Okay. That was the key. Don't use a base of 3.5.
Right. So 7 times 6.06.
So what is that? That's about 21. It's got to be D.
All right.
Okay. Find the equation of a line. What's the general equation of a line? Y equals what?
X plus B.
Okay. So we need to figure out M, and we need to figure out B. So what's M?
M would be the x-intercept, isn't it?
No, M is the slope.
I thought x was the slope.
No, M is the slope, B is the y-intercept. So
Okay.
this is a different line than the one they're telling us about here. The equation that they're giving us here, what's the slope on that line?
-3.
So what's the slope on our line that's parallel to that?
-4.
No, -3. It's the same. Lines that have the same, that are parallel to one another, have the same slope. In other words, if I draw a line here and I give it a slope of that, and I say, well, I have another line that's parallel to that, they have exactly the same slope.
Okay.
So when they tell you that it's parallel to this line, they're telling us what the slope is.
Okay.
Okay, so the equation of our line is -3x. We still don't know what b is, though.
Right.
But we can get this far. In other words, we know slope. So how can we figure out what b is? What other information have they given us here?
Figure out B. They gave us coordinates.
They gave us a point that our line goes through.
Right.
Well, if it goes through this point, -4, 6, then I must be able to plug in 6 for y and -4 for x, and then I'll be able to solve for b.
All right. So you'd have to graph it.
No. So all I'm going to do is plug in the y-coordinate of the point they gave us for y, the x-coordinate of the point they gave us for x, and now notice that I'm going to be able to solve for b.
All right.
This is +12. When I move it to the other side, it becomes -6. So b is -6. Now I have everything I need to write my equation. I know the slope is -3, and the y-intercept is -6. So there's my equation right there. So it's a two-step procedure.
Right.
It is figuring out what the slope is based on the fact that it's parallel, and then figuring out what b is based on the point that we go through. Notice that if I do graph something, and I know the slope, and I know one point, that's everything there is to know about that line. In other words, it's telling me it goes through this point right here. Well, if it goes through this point, and it has a slope of -3, there's only one line it can possibly be. There aren't two others. So whatever the equation of this line is our equation that we're looking for.
Right.
Remember that linear equations, if you have a slope and you go through a point, there is only one possible answer for that. Okay, on this one they want it left in simplest radical form also. Okay, now on this problem, it's tough to solve this using the Pythagorean theorem. Why? Because they've only given us one measurement.
All right.
That's the hypotenuse.
Right.
So if I can't use the Pythagorean theorem to solve it, I've got a couple of options. I can use my standard 60, 30, 90 triangle and do it by similar triangles. That's the way I would do it. But in order to do that, you've got to know the dimensions of this unit 30-60 triangle. What are they? What's opposite the 30?
I'm not sure. Is it 2?
No.
I don't
Okay.
remember.
So how about a trig function? Let's do it that way. Because you can't use these similar triangle methods if you don't remember the unit dimensions.
All right. Okay, so it would be SOHCAHTOA.
Okay.
So if you draw that right triangle again.
Well, let's look at this triangle here. We're trying to solve for x and y. We can do it in 2 steps. But
Opposite adjacent, so...
Okay, so what trig function would relate one of the variables we're trying to solve for and one of the numbers that we know?
Wouldn't it be a tangent?
Okay, so tangent of what?
Tangent of 24.
When you take trig functions, you're always taking trig functions of angles.
Okay. Tangent and 30 then.
Okay. Equals what?
Equals y.
Y over what?
X.
Well, that doesn't help me, does it?
No.
In other words, I don't want a trig function that relates y to x because now I have 2 variables and I can't solve that. So give me a different trig function that relates y to 24 root 3.
Oh, to 90?
No. The trig function that relates y to the hypotenuse is sine. Sine of 30 degrees is equal to y divided by 24 root 3. In other words, it's the opposite over the hypotenuse.
Okay.
So is this test, are you going to be allowed to use your calculator like with trig functions?
We are, and we're also allowed a note card, and that's what I'm taking note of here.
Well, if you're allowed a note card, we have 2 ways for you to solve this, but you have to tell me which one you want to use. In other words, we can use trig functions, but you're not terribly comfortable with those. Or we can use similar triangles, which to me is by far the easiest method. But if you're going to use similar triangles, you absolutely have to know the dimensions on this. In other words,
I just have to remember what the saying is, SOHCAHTOA, and like have it out in front of me. So if I write that on the note card,
okay.
I should be able to get that just fine. Opposite hypotenuse, adjacent hypotenuse, opposite adjacent, right?
Right. In other words, that's opposite over hypotenuse, that's adjacent over hypotenuse, and tangent is opposite over adjacent. So tangent was, you can certainly say tangent of 30 degrees is y over x, but you can't solve that because it's got 2 variables in it. So what you're looking for is a trig function that only has 1 variable. So how do I solve for, that solved for y because I was able to say sine of 30 degrees equals y divided by 24 root 3. So y is equal to 24 root 3 times the sine of 30 degrees, which is 1/2. So y would be 12 root 3. Now how do you solve for x?
Well, it's 12 root 3. You couldn't really use the hypotenuse there.
Well, actually you could now. Once you've solved for y, you could use the Pythagorean theorem. But, I mean, as long as we're using trig functions, let's use another trig function. It's a lot easier.
Alright. So then it would be the opposite to adjacent. So then it would be tangent, right?
All right, we could do that since we now know what y is.
Right.
Y was 12 root 3 divided by x. So now we have to solve that equation. So x is equal to 12 root 3 divided by the tangent of 30 degrees, which you can get out of your calculator.
All right.
Okay.
So 12 root 3 over tangent of 30. That comes to 0.
I don't think so. What's the tangent of 30? Tangent of 30 is root 3 over 3. So that should come to 4.
Oh, no, it was a error on my part. It's 27.35.
X is?
Yeah.
That doesn't match any of the answers we have.
You do 12 root 3 divided by tangent of 30.
Uh-huh.
That's what I did.
Okay. Hold on. I'm going to do it my way. I'm going to draw the unit and compare it to the unit. Okay, my unit has dimensions of this. So I know that my hypotenuse is 2. This hypotenuse is 24 root 3. So if I divide this hypotenuse by this hypotenuse, I get the scale factor. There's my scale factor. And now to figure out what y is, I'm going to take my scale factor and multiply it by the number 1, the side that's opposite my 30, to get y. And to get x, I'm going to take my scale factor and multiply it by root 3.
All right.
Well, 12 root 3 times root 3 is what?
12 root 3 times root 3?
Uh-huh. Don't do this on your calculator. Just tell me what that is. I want to make sure you know how to do that.
Wouldn't it become 12 root 9?
Yeah. What's root 9?
What do you mean, what's root 9?
Simplify it.
Oh, it comes to 3?
Okay. So it's 12 times 3, 36. So x is 36.
All right.
And y is 12 root 3, just like we came up with. Do you see why it's so much easier to do it my way?
Yeah.
So all you have to do is find the equivalent sides, divide them to find your scale factor, and then multiply that scale factor by whatever our smaller triangle sides are.
Right.
That'll give you every side of this triangle, because the scale factor has to be the same for every side relationship.
Right.
Okay. Okay, now notice that every triangle they give you has a 45, 45, or it's a 30, 60. So it's not accidental that I keep giving you these 30, 60 right triangles and 45, 45 right triangles, because every problem comes down to one of those.
Right.
So it's not really necessary to use trig functions here.
Okay. So it'd just be best to learn the
I would say that on your note paper that you get to take in with you, put two triangles down there, the 30-60 and the 45-45, and then solve all the problems based on these similar triangles.
Okay.
Copy these two onto your piece of paper. Not just the triangles, but the most important part is their dimensions.
Right.
There they are, right there. Okay?
All right.
So, given this is similar to this triangle on the right here,
Okay.
what is the altitude of this?
It'd be just 1, wouldn't it?
What's the scale factor of this triangle on the right with our unit triangle?
34 to 1.
You have to compare the same sides. You can't compare the 34 to the 1. The 34 is the hypotenuse.
Right, right.
So you have to compare it to the hypotenuse of this, 2.
34 over 2 then, right?
So the scale factor is 17 to 1. That's your first job, is to find the scale factor. So
Gotcha.
if the scale factor is 17 to 1, what is this dimension right here?
17.
Yes. Okay, so we know that this is 17. This is a 45-degree angle right there. So what is this dimension right here?
90.
The triangle on the left is a 45-45.
Right. I guess I'm confused on what you're asking.
If we know this triangle on the left is 45, 45, 90, and we know this height is 17, what is this dimension right here? It also has to be 17. These two sides have to be the same.
Okay.
Okay? So this little dimension is 17 right there. So what is x? What's the hypotenuse?
Hypotenuse is the square root of 17 squared plus 17 squared.
Okay. Let's use the similar triangles to figure out what x is. What is the scale factor between this triangle on the left and our unit triangle?
For x?
Yeah.
It'd be x root 2.
Well, it would be 17 root 2.
Right.
In other words, if this is 17 and this is 17, now I compare this triangle on the left with my 45-degree unit right triangle, which has dimensions of 1, 1, square root of 2. Well, I know that the 1 dimension is 17 on my new triangle, so the scale factor is 17 to 1. So this side here has to be 17 times root 2. In other words, I'm going to take that scale factor and multiply it by the hypotenuse of my unit. Excuse me 1 minute, Ryan. I got to bring something in outside. I'll be right back. Sorry about that. Have a little storm came in here, pretty nasty. Okay, so I'd really like to get you to a point where you can solve these problems based on similar triangles, because you can't always use the Pythagorean theorem. In this particular case, you can't use the Pythagorean theorem to answer this question. You can only use similar triangles.
How can you not use the Pythagorean theorem for this question?
Okay, tell me what I would say.
Well, because wouldn't it be, since there's 17 on the 45-45 triangle, wouldn't you do square root of 17?
Okay, you can use it to solve that one. But the original problem was we had to solve this right triangle on the right. How do you solve that using the Pythagorean theorem? In other words, we had already come up with the height. How do I know what that is using the Pythagorean theorem?
Well, if the height's 17...
But we didn't know that. We had to use similar triangles to come up with that.
All right.
In other words, we didn't come up with 17 by using the Pythagorean theorem. We came up with 17 based on the fact that this triangle is similar to this triangle, and this triangle is 17 times bigger than the unit triangle. Therefore, this side that's opposite the 30-degree angle has to be 17 times bigger than the side opposite the 30-degree angle in my unit triangle.
Okay.
And that's where we got 17.
Okay.
Okay? Now, once we get 17, yes, we could use the Pythagorean theorem. Knowing that this side here has to be 17, we know that x is the square root of 17 squared plus 17 squared. But it's still much easier to do, rather than use the Pythagorean theorem, let's use our 45-degree triangle. Which is 1 square root of 2. So we know this is 1, and in our triangle we know that's 17, so we still have a 17 to 1 scale factor. So the hypotenuse of this 45-degree triangle has to be 17 times bigger than the hypotenuse of this 45-degree triangle. So x is 17 root 2.
Right, and you can't solve
Well, that's 24. So it's either C or D. Okay, now to figure out why, we have to redraw this picture a little bit. So we know that x is 17 root 2. We know that this is root 7, that's 17. And we know that this is 17 from here to here. They want the measurement from here to here, so what we really need is from here to here.
Right.
So what is that? If this is 34, and this is 17, what is this distance right here, z?
Well, then wouldn't you use Pythagorean theorem there?
I guess we could, sure.
Or how else would you solve it?
Using similar triangles, because this is a 30-60. Once you get the hang of using similar triangles, it's far easier than the Pythagorean theorem. You don't have any big square root thing to deal with.
Okay.
You see how easy this is to solve for z if I know this. What is z?
17 root 3.
Yes. now we have everything. That means y must be 46.4. It certainly isn't 139.
Right.
Okay. See, these problems are just over and over and over. Oh, here finally we're going to get one that doesn't involve a 30-60 or a 45-45. That means we're going to have to use trig. Whenever you see an angle like 44 degrees, you know you're going to have to use trig. Because
Okay.
we don't have a unit triangle for 44 degrees.
Right.
Okay. So this is 4. This is 44 degrees. He's measuring it with a transit that's 4 feet tall. So here's the base of the transit on the ground. Here's the height, 4 feet. Here's the instrument that he's measuring it with.
Right.
And we know that this is 140 feet. So what he wants is the height of the pole. We'll call it h.
Alrighty.
So let's look at this top triangle here. This triangle right there.
Okay.
We know that it's 140 from that across here, right?
Right.
Okay. So give me a trig function that will let me calculate this measurement y, which is just from here to here.
Wouldn't it be opposite than hypotenuse?
No, we don't have the hypotenuse.
Oh, so it'd be opposite adjacent. So it'd be
Okay.
Tangent.
Good. Tangent of 44 degrees equals what?
Equals y over 140.
So y equals what?
Hold on. Have to do that on my calculator then.
Yeah, for
Let's
sure.
see. Okay, it's tan 44. So that equals divided by. How would you enter that in? Would it be tan 140, then you equal
No.
it?
It's the tan of 44 degrees times 140.
Okay, so then it comes to 0.83.
No, it doesn't. Take the tan of 44 degrees. Does that come to
Okay.
0.83?
No.
What's the tan of 44 degrees?
0.96.
Okay, now multiply that by 140. What do you get?
135.96.
Okay, so there's y. Now what's h?
Ooh, that would be h, wouldn't it?
No?
No, then you'd add 4.
There you go.
So it's 139 point, yeah, rounded just be 139.
I guess you got to choose D based on everything they've given us there. Okay? You get that problem? You understand my drawing?
Yeah.
Okay. As long as you have to be fluent in trig, then you could probably get away without using similar triangles. If you understand what I'm saying. In other words, you would not have had to use similar triangles if you're going to use trig, if you're really good with trig. and you're going to use trig instead. Wow, I'm looking outside here and I'm seeing skies just like I saw on TV in Oklahoma City here. Did you see all the destruction that those tornadoes did today?
No, I haven't.
They were showing it in real time on CNN. It is brutal. It just like a giant bowling ball went through Oklahoma City,
Huh.
a highly populated area. Okay, let's find the value of x. Again, we don't have a 30-60 or a 45-45 triangle, so we're going to have to use trig.
So it would be, again, tangent, wouldn't it?
Okay, so tell me what to write.
So it would be tan of 55 equals 8.9 over x.
Okay, now solve this for me.
Alright, so then you get tan of 55 times 8.9.
Be careful. Solve this, before doing any calculations at all, solve this equation for x.
8 point, what do you mean?
Well, let's rearrange it so that we're solving for x. What is x going to be equal to?
X equals negative tan 55.
No, not negative. Where'd you get the negative? In other words, we're going to multiply both sides by x. So we're going to have x tan of that equals 8.9. And then we're going to divide both sides by tan of 55. So x is going to be 8.9 divided by the tan of 55.
So it comes to 0.16.
Doesn't sound right. What do you give for the tan of 55?
Just tan of 55 is 1 point over.
What is it? 1 point what?
Is it? Okay, I did that wrong again. I don't hit tan, so then I'm just doing divided by 55.
Okay.
So it comes to 6.2.
Okay, that makes more sense. Let's be real careful here that you don't make this kind of mistake on the test. When you're solving this equation here, it's not so easy to do this on a calculator in one step. Like you said, there's lots of chances to make a mistake. So don't do it in one step. Do it in 2 steps. Figure out what the tan of 55 is and then just substitute it for that. And then you can do on your calculator 8.9 divided by 1 point whatever.
Okay.
Okay? When you try to do all of this on your calculator, it's too easy to make a mistake at one time. If you don't get your parentheses right, you're going to get it wrong. There's lots of things you can do wrong. So don't just do it in pieces. First of all, know how to solve this. You have to multiply both sides by x and then divide both sides by tan of 55 to solve for x.
Right.
Okay. So our answer then is 6.2. Now, believe it or not, we could have come up with that without doing any math at all. Why? Because this side, since it's opposite a 55-degree angle, has to be bigger than x, which is opposite a 35-degree angle. Remember that the biggest side of a triangle is always opposite the biggest angle? The smallest side is always opposite the smallest angle. So x has to be the smallest side of this triangle. Well, of the 4 answers given to us, there's only one answer there that's smaller than 8.9.
Okay.
Okay? So there's more than one way to skin a cat. But also, it's an excellent check. Whenever you do these problems and you come up with an answer, always kind of try to do a ballpark check. In other words, if we'd have come up with 12.7, I would have told you right away that can't be right. There's no way x can be bigger than 8.9.
Right. I see what you're saying now.
Okay. So what's the value of x here? This is a little different. Here x is in degrees. It's one of the angles. Can't use the Pythagorean theorem to solve this. The Pythagorean theorem would give us the hypotenuse, but it's not going to give us x in degrees. So what trig function right away could I use to solve this?
Opposite adjacent.
Give me the trig function. Give me the equation that I can write.
It'd be tangent of x. Would it be negative tan?
No. First of all, it's not negative tan, it's inverse tan, is what you mean to say.
All right.
And we don't have the inverse tan yet. What we have is the tangent of x is equal to what?
Tangent of x is equal to 19 over 11.
Okay. Now, to solve for x, we have to take the inverse tan of 19 over 11. But be very careful about calling that the negative tan, because it's not the negative tan. Negative tan is this. It's the inverse tan. That -1 exponent means the arctan, or the inverse tan.
Okay.
Okay. Now, on your calculator, look up the inverse tan of 19 divided by 11. And if that's a potential mistake for you, make sure you convert that to a number first. Find out what 19 divided by 11 is, and then find the inverse tangent of it.
All right, that comes to 59.93.
Okay, and that makes a certain amount of sense. This has to be a bigger angle than this one does. So if I came up with an angle less than 45 degrees, I would have known you made a mistake. Right? By the same thinking as the last problem?
Right.
The bigger side has to be opposite the bigger angle. Well, I know this has to be the bigger angle of these two. These two have to add to 90, and x has to be bigger than this one here. So 60 is a very reasonable answer.
Right.
Okay. Let's do one more here. Okay. This is relatively easy. We don't really care about the building. We only care about this right triangle. Right?
Right.
This is 72. This is 100. And they want to know the height of the building. Give me an equation that will allow me to calculate the height of that building.
I'm not sure.
What's the trig function that relates h to 100?
It'd be hypotenuse.
No.
No.
H is not the hypotenuse, it's the height.
Right.
One of the sides of that triangle.
Adjacent.
Of your three trig functions, sine, cosine, and tangent, sine and cosine both require the hypotenuse, which we don't know anything about here. So it's not going to be one of those two. It's got to be tan. Tan of 72 degrees.
What are we doing that for? 100 or 72?
72 is the angle.
Okay.
Remember that you always take trig functions of angles. You don't take trig functions of sides.
Right, well, it's oh, never mind.
So the tan of 72 is equal to what?
Tan of 72, that comes to 3.07.
Okay, and what is it equal to in my diagram?
Equals 100 over
TOA.
8.
TOA is what?
What?
TOA. SOHCAHTOA. What's the TOA stand for?
Opposite over adjacent.
Okay, so what's opposite to 72?
H.
Okay, so it's H over 100. Not 100 over H.
Alright.
Okay, so H is just 3.07 times 100, so H is 307. So the height of the building is 307 feet, or 308 feet. Okay?
Alrighty.
Okay, well I will talk to you on Wednesday at 3:30.
Alright, sounds good.
Okay? All right. Have a good one.
You too.
Bye-bye.
Thank you.